Today we have a couple of presentations. We're focusing once again on ingest workflows and staging areas. Scott Prater is here today. He was going to present in our June meeting, but we ran out of time. So Scott, thanks again for coming back. Appreciate it. And then I've also got a short presentation on kind of a new staging area that we've got set up for our team. So those will be the two talks for today. Let me pause there and let's take a look and see if we've got a couple of new attendees. Looks like Jane Kelly from Harvard Divinity School and also Stan Gunn from UVA. Would you all be up for doing a brief intro to the group? That'd be great.
Hi, this is Stan Gunn. I'm the Executive Director for IT at the University of Virginia Library.
All right, welcome, Stan. Thanks for the intro. And Jane, would you be up for introducing yourself?
Hi, yes. Can you all hear me?
Yeah. Mm-hmm.
Hi, I'm Jane Kelly. I'm the digital archivist at the Harvard Divinity School Library. Happy to be joining you.
Great. Well, thanks for joining us. Okay, let's see. All right, well, we definitely have critical mass here. Yeah, I'm trying to think. Robin, is there anything else you wanted to cover, like in terms of like just general information or anything?
I don't think so, other than to remind people that, inviting people from our talks, like both people that work across NDSA, but also people at your institution is always welcome. The more people we have involved in these calls, the more rich the discussion.
Yeah, definitely. So please feel free to reach out. That would be awesome. And spread the word. So, okay. Well, without just so we make sure we don't run out of time this time. So, Scott, are you ready to start your talk?
Yeah, I am. I do have some slides I'd like to share, if that's okay.
Okay, yeah, go for it. Thank you.
Okay, so let me start my presentation up here. And I got on. Peter Gorman, who is Digital Preservation Officer and Director of UW Digital Collections, is here also. And actually, a lot of these slides are ones that he came up with and presented on. And so I may ask Peter, or Peter may offer to jump in during this brief presentation. Okay, I'm just going to get my slides up here and get started on it. Okay. Close that one, go to this one. Slideshow. Okay. And share. Okay. Can everybody see that okay?
Yeah, looks good.
Okay, great. So I'm just going to give a brief high-level overview of our digital preservation repository. That this repository has been in production since, I believe, January. We spent about 18 months developing it, mostly through the COVID period. And it was funded by a Mellon grant that we got for putting online and preserving one of our art museums, Chazen Museum of Art, collections online. And a really good group of developers on it. One of the primary developers was Peter Winkles, who you may know from OCFL and OCFL Java. Anyways, it's been working really well, and I'd like to take a little bit of time to go over it. So very high level, what we have here, people create digital objects. They create things, and We create digital objects for digital collections, and this first side, the left side of the diagram over here, that um, we create digital objects and we put them in our Fedora repository, and that's kind of our source of truth. That's our canonical storage where we process them and make our digital collections objects available for discovery. And we also put them in the preservation service. Right now, digital collections is the only one using the preservation service, but we've built it out in such a way that we could go ahead and have other entities in the libraries and on campus, even perhaps eventually, deposit things into our preservation service directly. This is basically the workflow that things come in. So we're using bags as our SIPs, as our submission information packages. So people bundle things up in bags and they drop them off to us, and they can do that through the web, or eventually we'll sideload it. When we see a bag has arrived and it's been uploaded, it enters a state of received, and then we analyze it. And when we analyze it, we're basically checking it for viruses. We're analyzing the bags to make sure that the checksums are okay. We're also doing some format analysis. We're running fits on it, and we give some warnings if we see things that there's a conflict in the format or contradictory information in the format. So there's a lot of pre-processing that goes on in this analyzing phase to make sure that everything is okay before it goes forward. And if any of the analysis fails, it enters a failed state, and the person or the entity that submitted it will be notified of that. Then once it's analyzed and pass analyze, it goes into a review stage. And this is the only manual stage we have where it requires human intervention. So all these batches, basically a bag gets turned into a batch. They are pending review. And then somebody goes in and they can either, they'll see the results of the analysis. They'll say in your bag you had so many objects. Of those objects, there were so many warnings, so many errors. And do you want to go ahead with this or not? And then you can go ahead and either approve or reject the batch. If you reject it, then enters a state of rejected. And after about 60 days, it's deleted as if it never existed. If you approve the batch, then it enters a pending ingest stage where basically it just gets in line to be ingested into our preservation storage. And right now we have it basically go one by one for performance reasons, but in theory, we could do this in parallel. The objects enter an ingesting state where they're being copied to our local storage, which is university bucket storage. If it's run to the bucket storage, okay, then it past that. If it did not, it enters an ingest failed. And again, there's kind of a record of that, so we can go back and see what failed. Once it's in our primary storage, then we replicate it to our Amazon Glacier storage. And if that passes, it's complete. We now have 2 copies, a local copy and an AWS copy. Or if the replication failed, then we get a message about that. So that's basically the workflow of an object from the point it's received to the point where it's preserved. So here is a screen. Basically, we have the preservation repository set up so that there can be a number of organizations, which would be similar to tenants. And within a given organization, our organization, for example, is the UW-Madison General Library System, but we could have other organizations. Those organizations have vaults. And our vault The one we're using for digital collections is the UW Digital Collections one. And we can tell you how many preservation objects, how many objects are preserved there, the amount of storage used, and then the members of it. So every organization can have accounts created for members, and then permissions to do things in vaults can be granted to members within that organization. And then you can look up objects by their identifier. Like again, this is not a search and discovery. You need to know what you want to get things back out. Okay, so I'm going to run a brief video that Peter Gorman made a few months back. It's about 4 minutes, and he's just going to walk through that workflow that I just went over.
I'd like to demonstrate to you the administrative interface for our digital preservation repository. I've just signed in. And I see that I'm a member of an organization, the only one at the moment, so I'll go there. And right now I'm most interested in looking at the batches that have been submitted. Now the batches that I'm going to see on this screen can have any of the number of states. I'm most interested right now in those pending review because I'd like to get these submitted as soon as possible. So when I apply the filter, I see that there are 26 batches, which correspond to bags or SIPs, that need to be reviewed before they can be ingested. I'll pick this first one. Note that it has some basic audit trail information, timestamps, who submitted it. And I can see down here right now that fortunately, there are no warnings or errors for any of the objects in there, but if I'd like to look at any of them, I can. This will show me the objects in the batch. If I scroll down to the files, if I want to look at file statistics, now I can't retrieve the file itself at this point, but I can see things like the checksum, the size, the content type that was submitted with the object, but also those generated by FITS, and the pronom ID that FITS supplied, and also validation information. The same is true for other file types. If there are errors or warnings for any of the files, they would show up in that part. So since everything seems to be okay, let's go back to the batch. I will approve it. Now that it is approved, we'll go back to my batch view. I'll see if I look at what's pending review. If I refresh that list, my batch is no longer there. I'll see if it's ingesting. It's not yet, so I'll look at it's pending ingestion. And that means right now that some other job has taken precedence over that. At the point when it does ingest, if the ingest goes successfully, it will go transition to a state of replicating. And this, in fact, is a previous batch that I approved, and it's replicating now. When that job finishes, then the batch that I just approved will be ingested, and then it will also move to replicating. And assuming the replication goes well, we will go to complete, where it will join almost 3,000 batches to date for our repository that have been successfully ingested. I just look at those that are reviewed. I can then, what I normally do is just go through and approve batches one by one. And then they'll transition through this pending and ingesting states until all of them have been successfully processed. To date, we have little over 787 objects preserved in our preservation repository. Thank you.
Okay, so
I'd like to demonstrate.
sorry about that. Here we go. We're actually very close to 1 million objects now, since Peter last created that. Before I get into kind of the storage and underlying infrastructure that the system's built on, I just want to pause and see if anybody has any questions about this, about the user interface and how the system works from the user point of view. Okay, so for the remainder of the presentation, I'm just going to talk a little bit about our high-level architecture. So basically, we have SIPs that can come from anywhere. We can either put them in an upload area and then have them move to the loading dock for the preservation manager. Or for our digital collections, we actually have a nightly service that looks at everything that's been created or updated in the previous day, and it bundles it up into a bag and then puts it on the loading dock. So yeah, we have the upload area that gets moved here, and then things go to the loading dock, and that's when they enter the state of receive, when things get transferred to the loading dock. Once they've been received, then they get copied over here to the preservation managers and processing area, and that's where the analysis takes place. The bags are unzipped, the viruses are checked, the bags are checked for being complete and correct, and the checksums are verified, and then the format bits is run on the formats. Once everything has been okay there and it's been approved, we put them in an OCFL repository that we have on a local S3 bucket storage. And then once they're copied there, they're copied to a staging area for replication. And from the staging area for replication, they're copied to our secondary storage. And we use the AWS S3 lifecycle service, which basically things get copied to S3, and then they are copied from S3 to Glacier within about a 24-hour period, I think it is. The nice thing about this storage class is that you can upload things fairly quickly to it, and you're charged only Glacier prices. You're not charged S3 prices for the time that the things remain in S3. So it's really a kind of cost-effective way to get things up into AWS quickly. You can look at the things during the period that they're there in S3 before they're copied to Glacier without being charged for the Glacier analysis or retrieval costs. Okay, and then I'm not going to go into how dips are generated, but we've also run testing and have generated dips. And basically what we do is we can generate a dip for a list of objects that are in a vault. So again, somebody would need to say, I need these objects for a vault, or we can create a dip for everything in the vault. As is standard with preservation systems, we're very explicit and upfront about the fact this is not a backup service, and this is not a search and discovery service. It's for disaster recovery or recovering things after a very long time when they're not. So basically, we don't encourage people to ask for dips unless there's like a real business need for dips. We do encourage people to still use backup for the normal continuity of operations for their materials. The idea is that if we get a request for a dip, we would pull that off of our local primary storage the OCFL repository that our campus has. And we would only go to the AWSS3 in the event of like really big disaster where the OCFL repository locally is not available. Because as everybody knows, if you're pulling things out of Glacier, you're going to get charged a lot for that. Our local system, we don't have any charges for retrieval. So that makes it pretty cost effective there. So basically we get the list, the preservation manager takes a look at the list of things, pulls it from our local OCFL repository. We do supplement or enhance the DIP with the premise metadata and technical metadata that we create when we ingest something, and we add that to the DIP. So they don't get exactly what they put in, they get what they put in plus some administrative metadata and format data that we've created during the process of ingest. And as you can see, the preservation metadata there is pulled from our preservation database. And I'll just say that the preservation database itself, it's a Postgres database, but we back that up and preserve it both in our primary storage and in AWS nightly. So the idea being that if everything were to go to hell overnight, we would have all the information we've gathered and collected about these things stored offsite and be able to be retrieved and handed back to somebody at a future date and time just from our preservation storage. Okay, and the last thing I want to point out is that under the terms of the grant, we agreed to make available all the source code for the preservation service. And so we've divided the preservation service into 3 distinct pieces, all available on GitHub. One is the core backend service. The other one is the front-end web app, what you've seen us kind of walk through. And then the things that glue the web app to the service is an API. And anybody could write their own web app to interact with the service using the preservation API that we've come up with. And so those are the 3 things we've made available through GitHub. We're happy to have anybody go out and look at it. We don't have many cycles for support. We hand these things out as is, and it's up to anybody who wants to use it to kind of adapt and set it up for their own needs. That said, of course, we're available for questions or help if anybody were interested in kicking the tires or setting this up for themselves. And with that, I'll stop my share and turn it over. Peter, before we open it up for questions, is there anything you'd like to say or add?
No, that pretty well covers it. We're up to almost 1 million objects now since that little video was done. So things are moving along pretty well. And we have also, we tested each of those system states during the testing phase of that, and we've encountered most of them actually in the early stages of production. So at least we know that our recovery options for different fail states work.
Okay, and so I'll kind of turn it over to open discussion questions. Anything anybody would like to ask or comment on?
I have a quick question. So what happens to the content that failed on the ingest or replication stages? Do you attempt to repeat the ingest and replication, or how would you process that?
Okay, yeah, if it fails during initial ingest, then it just enters that and we see a list of that. And there is no way to retry an ingest with that. In that case, basically what we do is we'd ask the content provider to resubmit. There have been cases where because of power outage events or other things going offline where an ingest has failed and things have gone in a stuck state. In that case, we have the service administrator go under the hood and redo those ingests. And that is something we have as kind of a phase 2 to make a little bit more resilient. Our reporting is good. We know when those things happen and we can identify the things that are in that state. Recovery is still very much manual and under the hood. And so that's something where we need to do more work. In terms of the replication, it just enters replication failed state. There's no attempt to retry replication. And again, we have to go in under the hood and figure that out and retry the replication or see what went wrong and fix that manually. But we have pretty good tracking. We also, at least for our digital collections in our Fedora repository, we set up an audit service, an audit toolkit, so that we can go back and periodically do reality checks between everything in our Fedora repository that we think should be preserved and is marked as preserved and what's actually in the preservation database.
Thank you.
And to that, I'll add that when there are ingests that are failing because of, say, a malformed object, that can only be resolved by the person, by the entity submitting the objects. That's when we just ask them, we kick it back, the messages back to the provider and tell them either fix the object and re-ingest or, ignore it.
Nathan?
Hey, thank you. I have two questions. One, what happens if an object is deleted from Fedora? How does that pass through and affect the preservation vault? And the second question is regarding the storage. Are both of those the primary and secondary separate OCFL storage routes? Thank you.
Yeah, so for the first question, we do not handle deletions at all. The idea that things can be deleted from our preservation repository is anathema to us. And we actually just wrote up a policy document kind of outlining under what conditions we will delete something from our preservation repository, who has to give approval, who or what groups of people will be in charge of doing that, with the idea that there's no one single person in our organization who has access to all our copies of stuff in all the different replications. So we very deliberately decided very early on that we were not going to support deletions except by a manual service administrator process. And Peter, if you want to kind of talk through that a little bit.
Yeah. We have had cases where we've seen retrospectively that say an object was submitted twice to our Fedora repository and they wanted to dedupe it. We're actually talking through whether to use that same policy and request that the thing be deleted from the preservation repository as well, but we would keep an audit trail of all communications regarding that, and that's a rare event. The other rare event would be, say, if the grad school tells us that a dissertation for legal reasons needs to be withdrawn or retracted, again, that would fall under our policy. It would be removed from the Fedora repository. There'd be a tombstone kept. And we would use that same deletion policy, keeping the audit trail and trail of authorizations to remove it from the preservation repository. So we can react in those rare cases when something is deleted.
Yeah, and regarding your second question about separate OCFL routes, I don't want to dive into the details right now because they're pretty detailed. but the primary is a single OCFL repository for a number of different reasons, which I won't go into. The AWS is basically kind of snippets of OCFL version, but not under a standard OCFL root. And I'd be happy to talk with you more offline about what that is and why we do that, but it's getting into pretty deep weeds there, which I barely can grasp myself on any given day.
No worries. Thank you very much.
Scott. I have a question for you. So across the OCFL components of the architecture, did you all leverage any publicly available libraries or anything like that in terms of like Java or Python or anything like that?
Yeah, so for the bags, we the Fedora service, transfer service that creates the bag for our objects, we actually use the Library of Congress Baget software, Java software. There's a bit of a long history and back and forth with the original developer of that, and we ended up doing our own forked version of that code, partially for license reasons, partially for support for the Baget 1.0 spec. So we're using that as basically the SIP creator. We're using FITS and the FITS library under the hood for our format analysis. And FITS is very nice and has a built-in Java library too. So you don't just have to use it from the command line. And we actually stood up a FITS web service that the preservation system uses to analyze the bags and check checksums. We're just using that same Baget library. Pretty much everything is built. Yeah, the OCFL is using OCFL Java. Pretty much everything is built on open source components.
Okay. Yeah, and open sourcing the entire repository software is amazing. That's awesome. And one other follow-up question. So in terms of metadata for the bags, and I guess through the Fedora output, are there? I assume there's a standard set of metadata or a profile or something that's there, or do different depositors use include different types of metadata or amounts?
Yeah, as far as that goes, we deliberately designed it that anybody can do anything, basically deposit anything. We don't care if it comes in a bag. It should have the required bag metadata files so that we can validate it. But in terms of the content payload, we don't care. It can be anything we want. It's up to the provider to decide what metadata they want to provide. That said, that we do generate and store our own technical metadata and format metadata that, as I said in the DIP, we actually return that as a premise XML document that becomes part of the data payload of the DIP bag that we give back to the provider.
Got it. Okay. Yeah, thank you.
Yeah, we're also agnostic as to what an object is. So Fedora has its notions of what files may be included in an object, but again, that's really up to how people construct the bag. And that's another reason we didn't prescribe particular kinds of metadata, because they could attach at any level of granularity potentially in an object, and different disciplines may have different standards they'd like to use. And since we're not providing a discovery interface within the preservation service, we felt it wasn't really important to try to bind people to particular metadata schemas.
That said, as part of the service, when we start rolling it out to other groups in the library and then conceivably campus maybe in the future, one of the first things we do is we kind of sit down with them and have a kind of interview orientation process where we talk about preservation at large and all those kinds of things. But then we also talk about what is the logical unit that makes sense for their content. As you wouldn't want, for example, our entire digital collections to be one giant object and one giant bag, for example. On the other hand, every single data stream in our file repository, that wouldn't make sense either. So every content provider will have something that is a logical unit for them, and that's something we'll talk about with them and how well that would serve for preservation.
Got it. Thank you. Let's see. I don't see any other questions in the chat. Do other folks have questions for Scott and Peter?
Okay, thank you, everyone.
Yeah, thank you so much. Thank you both for the presentation. And as we usually note, we'll have this recording up on YouTube within a week or so. So if folks want to refer to anything that's been presented, that will be available as well. Let's see. All right, so there's also, I'd like to present a kind of a quick presentation on a kind of a staging area that we've built at CDL recently to help our depositors when it comes to interacting and staging content. So I'd like to go ahead and do that. Go ahead and share out this presentation. Okay. So can folks see that? All right, great. So this is actually a project that we took on because it's mainly something that we've thought about a lot in the past, and I think it's a very common use case. So I'll just start out with a problem statement. So across University of California, across all the campuses, many libraries, departments that are interested in preservation projects, they really have limited resources to apply towards like archiving their content, and whether or not that means interacting with the dams and adding content and metadata and everything like that, curation practices versus actually working with a digitization vendor and getting the content together, and kind of runs the gamut where folks do and don't have the cycles to apply. So they'll tend to, they'll have control over all the catalog records and metadata, and they might be working with a vendor, but they might also just where that process ends could be either copying that content to a transfer device or hard drive of any sort, or it could be staging that content at their campus for our preservation repository to actually go and download it. But yeah, again, it's like a whole variety of situations that we encounter. So what we wanted to do is to try to find a way to make some of those cases a little bit more efficient. So what we ended up doing really is like enabling the acquisition and having space to work with that content. Many times we've talked about having a dedicated workstation at our office. We've talked to internal IT about this. They're not really excited about A, using anybody's laptop, B, providing a separate workstation. And this is for us when, say, a hard drive is handed to us, or maybe an AWS like Snowcone or other transfer device or something. And we don't necessarily want to keep those drives around for a long time. They belong to digitization vendors or to the libraries themselves. So that's kind of a liability for us as well. So especially for this hard drive case, we needed an environment that we could take that content from the hard drive, put it up into a space and work with it readily. Whether that means, adding checksums, packaging, changing file hierarchies and, directory hierarchies and all that kind of stuff. As agreed to when we're working with this particular library or any library. So, what could we do that didn't require a workstation to be sitting around when it wasn't going to be used, if one of these projects is no longer in play. And then, of course, it's got to be something that's securely accessible, that is locked down, and so on and so forth. Um, so this is pretty much a way for us to make a bridge between, the output of or the content that's given to a library from a digitization vendor, and then, whether that means it's going to be on an S3 bucket or whether it's theirs or ours or anything like that. The notion is to put that into a space and have that space available to our repository services ingest service. So that is kind of the base, that's what the outlook is, or that's what we wanted to do, especially for this case where we have files coming in via hard drives and other devices. And this is kind of what we came up with, which, if you take a look at just the first, the step that is, important for us to take the content from the hard drive and put it into an S3 bucket that we own, is something that we can do directly via connecting that drive to any workstation or anyone's laptop, and then through AWS SSO authentication, we can copy that up to a bucket. So that's this top part here. But then what the really interesting and neat part is, at least in my mind, is that once it's up in that S3 bucket, what we do is we spin up an EC2 instance, and then we use this service from Amazon called FSX for Lustre. The Lustre file system is something that's been around for quite a while. It was originally conceived of back in, I think, 1999, and I think in 2007, Sun Microsystems made it available. And it was originally, I think it was a Carnegie Mellon project before that. So it's been around for a long time, but essentially what it does is it makes a connection between our S3 bucket and that EC2 instance. So what I can do is log into the EC2 instance, and instead of having to know all these S3 commands, and instead of having to go through that command line interface where you can't really do things like, easily move or copy things, like S3 requires you, if you want to rename something, you have to make a new copy of the file and rename it during the copy and then delete the old file. Operations like that are not something that many folks are familiar with at the command line, but a lot of folks are familiar with standard bash shell scripting and everything. So what the solution does is it really enables you to use any kind of shell scripting and bash interaction to prepare those files that are up in the S3 bucket. So it's really familiar to more people, and to anybody on our team, that if we need to interact with these files and prepare them in any other way, we can do that really easily. And then when we're done with a project, all of this, the configuration for this EC2 device and the Lustre system, file system in the S3, that's all stored as configuration management. So we can just kind of tear down this whole system when the project's over, and then if we need to reinstantiate it for another project down the road, we can do that. So I think, to me, the amazing bit is being able to interact with an S3 bucket straight from a bash, command line and a shell. Let's see, get out of here really quick, and then, what time is it? It is, okay, we've got a few minutes left here. So I just wanted to show folks really quickly what this looks like. I can actually, we'll stop that share and share one other thing. Let's see. Okay, so this is probably a little on the small side. I don't know if there's much I can do here, but this is VS Code, which is just, it's the Microsoft's offering for a development environment. And so in the middle here in this terminal window, if I clear this out, I can essentially see all these different directories that are sitting here. And they are directories and files and everything that are in an S3 bucket. So I can easily like interact with any of these things if I want to like change the name for any of these guys. I can essentially say, and then you can see that all these things are here just like in a normal bash shell. So it's very easy from that standpoint. And now I can like work with all these different directories and everything to, change whatever I need to, and then maybe create zip files or create packages for ingest into the service. And then the service itself has access to that S3 bucket, and we can go from there. So yeah, that was just a quick walkthrough of a staging area that we've recently built to enable us to assist depositors with their submissions. Oh, and Nathan, thanks for dropping that link in for the FSX Lustre and file system there from Amazon. I just want to pause there for any questions. Yeah, Scott?
Yeah, so is this just for Amazon S3, or would it work with any S3 file system, the FSX for Lustre?
That's a very good question. I'm pretty sure it would work with any kind of S3 API. So if you wanted to interact, like if the bucket was defined at another service provider like Wasabi, I imagine you could probably connect it that way, because the Lustre file system, that whole service, FSX for Lustre, is an individual service. It doesn't necessarily have to be, it's not linked to like Amazon S3. So I can confirm that, but yeah, that's a really good question.
Okay, thank you.
Yeah. Mm-hmm.
I have a question. Do you have safeguards from the human errors if your depositors have access to the S3 bucket? How do you safeguard from, say, accidental deletions?
Right. Yeah, that's a good question. Right now, we have access set up strictly through the AWS SSO login, which all these resources are available only in our AWS account. So right now, depositors don't have direct access to the S3 bucket. And the only way to get to it is literally have access to that AWS account within the CDL network. So like our IT folks have set up that access, and I have a specific logon just like anybody else on the team has a logon, and that's it. So if we were to make this available directly to depositors to the S3 bucket, I think that would be a different story, and we would definitely want some other safeguards in place. So, but right now it's really locked down.
Thank you.
Yeah, sure. Any other questions? Okay. All right. Well, we're approaching the top of the hour here, so I think we should start to wrap up. Again, the next meeting is on December 10th, and we'll be reaching out to folks about that. And Robin, is there anything else you wanted to mention before we wrap up?
No, just that if anybody is closing out the year and there's something in particular off of the topics list that you wanted to hear, that, you should let us know. And also, because we didn't have DigiPres this year, like we usually do when we have the presentation and we gather ideas for the coming year, Eric and I'll be working on that to get topics together. Right?
Yeah, we'll put up another poll there for folks to vote on topics and add any input areas they'd like to talk about. So yeah.
I mean, the
sounds good.
current format and the current cadence of our meetings seems to be working for people. But if you have an opposing opinion about that, you should let us know.
Right, yeah. Please let us know. And right, we've had these kinds of presentations. We've also had like something we didn't do this year was the kind of reading reading club kind of thing where we review a few articles ahead of time and discuss them. So we could also think about doing that for the December meeting if we wanted to. Yeah.
Pick out one of the topics off the topics list and do that.
Right. Yeah. Okay. All right. Well, that pretty much wraps everything up. Thank you very much, everyone, for attending. It was great to see folks here. And hopefully we will see you in December as well. Take care.
Thanks, Eric.
Thanks, Scott. Thanks, Peter.